Hi everybody, welcome. A very warm welcome to this short and sweet video, which by the way is going to be super duper impactful. It is going to add tons of value to your preparation, I can promise you. And by the end of this video, you are going to thank me for sure. What is this video about? This video is going to reveal JEE Main's most wanted concept. This is that concept, that idea, that topic from where more than 33 questions have been asked in the last 5 years in JEE Main. That means this concept is absolutely favorite, absolutely dear to the JEE Main community. Well, let me tell you, this is also a very easy concept to master, and if you master it, if you excel at it, you are going to guarantee 4 to 8 marks in your pocket just like that. It's so easy. It's a supremely low input but a tremendously high output topic. What is it? What is all this hype about? What is this subtopic? Any guesses, any clue, anyone? This is none other than, yes, you guessed it right, properties of adjoint of a matrix. Yes, people, you already know matrices and determinants is a very high weightage chapter, but from within this chapter, this subtopic specifically holds extremely high weightage individually. Every single year, in every single shift, 1 to 2 questions can be expected from here for sure. And what is it about? These are just handful of properties which you have to master and keep them on your fingertips. If you remember them on your fingertips, trust me, any question which comes from here, you are going to crush it, smash it, kill it. Guaranteed 4 to 8 marks. Are you ready to master these properties in just a few minutes? Let's go then. But before that, let me show you the volume of questions which has been asked in the previous years, in just last 5 years, people, just from this concept. So these are around 6 to 7 properties, and you can just see behind me, so many questions have been asked. All of them based upon just the 6-7 properties of adjoint of a matrix. Isn't that mind-blowing? At this time, when we are so close to our JEE Main exam, getting to know these short topics, which if we master, definitely 4 to 8 marks we can earn. This is a boon. This is literally a boon. And that is why I said that this video is going to add tons of value to your preparation. And by the end of this video, you are definitely going to thank me. So let's get started, people. Let's get started to ace these properties of adjoint of a matrix. Let's go. Let's go, everybody. Get ready with your pens and notebooks. The first property says determinant of adjoint of A is determinant of A to the power n minus 1. Here A, mind it, is a square matrix of order n. Let's go ahead to the next property. Adjoint of A is determinant of A to the power n minus 2 times A. That means adjoint of A will turn out to be a matrix. The answer is it will be scalar multiple of the matrix A. What is the scalar attached here? Determinant of A to the power n minus 2. Moving ahead, very important property, people. This is so important. You can make as many stars as you want at this property. This is a very repeated property in the JEE Main exam. Determinant of adjoint of A is determinant of A to the power n minus 1 whole square. This calls for an observation. We have to pause here and observe what's going on. I want all of you all to please pay attention. See, keep looking. Here it's written adjoint of A. That means adjoint is here written twice. And in the power of n minus 1, again, you can see the number 2. Hence, we can extrapolate this property and also write this as, if I have adjoint of A, keep looking. There is absolutely no need to get distracted. Keep looking. Here, what did I do? I wrote adjoint 3 times. As a result, what will be my right hand side? It will be determinant of A to the power n minus 1 to the power 3, people. That's how easy it is. Easy peasy lemon squeezy. Extrapolated to the most general scenario. If I have adjoint of A, that means I am attaching adjoint how many times? K times. Then as a result, what will happen on the right hand side? This will be determinant of A to the power n minus 1 whole to the power K. That's it. How many ever times adjoint is written on the left hand side, that number jumps to the power of n minus 1 on the right hand side. Extremely important, supremely important property, guys. This is very, very important. You cannot afford to forget it. Ready for the next one? Adjoint of A transpose is adjoint of A whole transpose. Very intuitive, very, very easy. Adjoint of K times A is K to the power n minus 1 times adjoint of A. What is this? What is this? Somehow it's reminding me of a property of determinant. Is that happening to you? We have learned, what have we learned? We've learned determinant of, let me write this in the manner that you have seen it. Determinant of K times A is K to the power n times determinant of A. You remember this? So K comes out of the determinant with the power n, where n represents the order of A. Yep. Here what's happening? We have adjoint of K times A. K is coming out of adjoint but with the power n minus 1. So that's how these two properties kind of resonate but not completely, and hence it's easier for you to remember that okay, these two are actually not the same. They don't function in the same way. They don't behave in the same way. Up next, we have adjoint of A to the power m is adjoint of A whole to the power m. M can be any integer. Similarly, you can extrapolate it for inverse as well. Like if you have adjoint of A inverse, this is nothing but adjoint of A whole inverse. Okay? So A inverse, the adjoint of A inverse is nothing but inverse of the adjoint of the original matrix. Moving ahead, we have a very beautiful property. This is called the reversal law of adjoint. Just like we have reversal law of transpose, reversal law of inverse. What does that say? What does that say? Adjoint of A into B is adjoint of B into adjoint of A. What do I mean? Adjoint of product is product of adjoint but taken in reverse order. Just like reversal law of transpose. Transpose of product is product of transpose taken in reverse order. AB transpose is B transpose into A transpose. Remember? Similarly, we have reversal law of inverse. AB inverse is B inverse A inverse. Okay, so I am just making you recall all the properties which are associated so that these ones you can remember very easily. Alrighty, that's it, people. This was the end. Now, we are going to do some warm-up. Quick warm-up before I take you to the actual battlefield where I will be shooting some brilliant PYQs at you so that you can understand how to apply these properties, how to think and navigate through the question, understand which one needs to be applied where. But before that, as I told you, let's quickly warm up. The first question, determinant of adjoint of 3A. What are you going to do here? What are you going to do here? See, super duper simple, people. It's super duper simple. You can treat 3A as an individual matrix B, let's say. What do you have then? You have determinant of adjoint of B. You have learned the property, determinant of adjoint of A is determinant of A to the power n minus 1. Very important property number 1. So this will be determinant of B to the power n minus 1. Here, the matrix has order 3, so 3 minus 1 is 2. Yes or no? But what is B? B is nothing but 3A. B is nothing but 3A. What will happen now? Now I want you to recall the property that determinant of K times A is K to the power n times determinant of A, where n is the order of A. So what will happen here? Very careful, very, very careful. This is determinant of 3A whole square. So 3 will come out of the determinant with the power 3 because 3 is the order of A. So you will have 3 to the power 3 determinant of A and all of this square. Understood? Yes, people, I hope there is no confusion till here. What will happen now? 3 to the power 6 determinant of A square. Now, determinant of A is given to you as 6. So, 6 you can substitute in place of determinant of A and bam, you've got your answer. Easy peasy lemon squeezy. Yes or no? Whenever we are able to crack any question, we are going to write what? We are going to write hashtag HDCC. High definition crystal clear. High definition crystal clear. So, this question, hashtag HDCC. Up next, what is the next one? Slight variation, slight modification, determinant of 3 times adjoint of A. What is happening now? Again, careful, okay? The antennas have to be actively up all the time. Determinant of 3 times adjoint of A. Again, you can treat adjoint of A as a matrix B. This will look like 3b. And this is very much familiar. This will be what? If A is a matrix of order 3, adjoint of A will also be a matrix of the same order 3. So from here, 3 to the power 3 determinant of B, right? I have applied this property yet again here. So I am getting 3 to the power 3 determinant of B, which is determinant of adjoint of A. Again, 3 to the power 3 determinant of adjoint of A is determinant of A to the power n minus 1. Yes or no, people? Can you see this? 3 to the power 3 and determinant of adjoint of A I have replaced with determinant of A to the power 3 minus 1, which is 2 because 3 is the order of A. Up next is this question also. Hashtag HDCC. It's killed, it's smashed, it's crushed. We have conquered it. Feeling confident? The confidence has to increase gradually. Correct? Alrighty, determinant of adjoint of 3A. With this property, you should have a big smile on your faces, people, because this is reminding us of the star property, the superstar property, which had all the spotlight on it. What is it? Determinant of adjoint of A, where adjoint is written k times, is determinant of A to the power n minus 1 to the power k. Cool. Here, adjoint is written twice. So I will write determinant of 3A to the power n minus 1 to the power how many ever times adjoint is written. Correct? So you are getting determinant of 3A raised to the power 4. Now here again, this is what? Determinant of 3A whole raised to the power 4. That's what it is. Realize. Now 3 will come out of the determinant how many times? 3 times. So you are going to get 3 to the power 3 determinant of A whole to the power 4. This will give you 3 to the power 12 determinant of A to the power 4. Plug in the value of determinant of A as 6 as given above and you are done. Again, hashtag HDCC. Moving ahead. Fourth is this. Determinant of adjoint of 3 times adjoint of A. What is this? Again, here what can you do is you can play smart. You can play smart, treat this as the matrix B. So what will happen? This will give you determinant of adjoint of B, correct? Which is determinant of B to the power n minus 1. But B is nothing but 3 times adjoint of A. Yes or no? So you are going to get 3 will come out of the determinant with power 3. You will have determinant of adjoint of A, all of this to the power 2. So this will give you 3 to the power 6 and determinant of adjoint of A to the power 2. But determinant of adjoint of A is determinant of A to the power n minus 1 to the power 2. So you are going to get 3 to the power 6 determinant of A to the power 4. See, once you are able to kind of match that, okay, this situation calls for that property, once you're able to connect which situation calls for what property, applying it becomes very easy. It's a cakewalk. It's like a walk in the park. Seriously. Up next is this. Again, this is super simple. 3 times adjoint. Determinant of adjoint of A is determinant of A to the power n minus 1 to the power 3. Yep. Yes, so this will give you determinant of A to the power what? 8. Alrighty, up next is this one. This is slightly different than the previous one. Determinant of adjoint of 3 times adjoint of A. What will you do? See, very, very simple, people. Just treat 3 times adjoint of A as B. We have to kind of manipulate the given expression into something which is familiar to us, into something which kind of fits in a standard formula setup. And that much I think we mathematicians can very easily do. So this will become determinant of adjoint of B. Yes or no? This will give you determinant of B, the superstar property, determinant of B to the power n minus 1 square. So determinant of B to the power 4, but this is nothing but 3 times adjoint of A to the power 4. So 3 will come out 3 times, power 4 will give you 12. Yes or no? Yes or no? 3 will come out 3 times of the determinant to the power 4. So 3 to the power 12 and determinant of adjoint of A to the power 4, which is determinant of A to the power n minus 1 to the power 4. So this will give you power 8 and bingo, you have your answer. Look here. Okay. Okie dokie. Yup. All these questions, hashtag HDCC everyone. This was just the warm up. I wanted you to directly understand how to apply the properties. How do we have to manipulate the given expression to kind of fit in the standard setup so that the properties get applied easily. We are able to see that how, when, where to apply the property. So if this much you've understood, you've developed a firm grip over the properties. Congratulations. And with that, let's jump onto the battlefield. Let's attack some very important, very insightful PYQs based upon the same concept. Now here, this one is a 2024 question. It says A and B are two square matrices of order 3 each, such that determinant of A is 3, determinant of B is 2. What is the value of this massively long, dense, scary expression? Now, these question-minded people are very easy. You would have realized by now, if just you remember the properties, applying them, cracking these questions is actually an easy task. But what makes these questions difficult is they demand a lot of focus. They demand a lot of attention. The moment you're distracted for even a second, it's lost. It's gone. The marks are off the table. These 4 easy to win marks are off the table for you. So stay attentive. Let's go. Look at this. Look at this question. We have to simplify this. We have to compute the value of it. You already know here, so many matrices are actually multiplied with each other and eventually we have a determinant, right? This reminds me of the property straight away that determinant of A into B is determinant of A into determinant of B. Yes or no? Yes or no? Determinant of product is product of individual determinant. So here what will you get? You will get determinant of A transpose into determinant of A into determinant of adjoint of 2A inverse. So this is adjoint of 2A whole inverse. Adjoint of 2A whole inverse. Let me write it properly so that there is absolutely no confusion. Alrighty, inverse and then determinant close. Next matrix is adjoint of 4B. So determinant of adjoint of 4B. Correct? Next up is adjoint of AB inverse. Adjoint of AB and then inverse. That's it. Next is determinant of A. Next is determinant of A transpose. Yup. I just broke my determinant onto every single matrix written in the question, written in the expression. Now, determinant of A is already given to you as 3. You know determinant of A transpose is same as determinant of A. Yes or no? You know this? So this is also 3. This is also 3. This is also 3. So eventually these 4 quantities are smashed. The answer is 3 to the power 4. So 3 to the power 4 I hope is understood. Next up, what do we have? Determinant of adjoint of 2A inverse. Now, adjoint of 2A is the matrix whose inverses determinant we need to compute. For that, I want you to recollect the property. Determinant of A inverse is 1 upon determinant of A. Yes or no? Have a smile on your face. This will give you 1 upon determinant of adjoint of 2A. Next up is this one, determinant of adjoint of 4B. Right now, we have learned the property. Just right now, we learned the property. Is it striking? Is it knocking the doors of your memory? Determinant of adjoint of A is determinant of A to the power n minus 1. So this will be determinant of 4B to the power n minus 1. Yes or no? Yes or no? Because B is also a matrix of order 3, A is also a matrix of order 3. Okay, next is determinant of adjoint of AB inverse. Again, this will be 1 upon determinant of adjoint of AB. That's it. Yes or no? Is this clear? Is the story clear till here? Up next, we are very close to our answer. Now, this is what? Determinant of adjoint of A again is determinant of A to the power n minus 1. This will be determinant of 2A to the power n minus 1, 3 minus 1. This will be what? 4 cube determinant of B, all of this square. How did you do this? Because determinant of K times A is K to the power n times determinant of A, where n is the order of A. That's how I did it. Cool. Up next, what is this? 1 upon, what is determinant of adjoint of AB? Guys, remember, adjoint of AB was nothing but adjoint of B into adjoint of A. That's the first step. Adjoint of AB, you remember, was adjoint of B into adjoint of A. But again, this is one matrix. This is another matrix. So determinant of product is product of determinant. Determinant of product of two matrices is the product of their individual determinant. Yes or no? So on the next page, let's quickly write this. This is 3 to the power 4 as it is, multiplied with, let's quickly check what was it that we had in the last page. Yep. Quickly check the calculation. These are quite calculation sensitive questions. 1 upon determinant of 2a whole square. How do you think you will resolve this? Any idea? How do you think you can resolve this? 2 will come out with power 3 and you're left with determinant of a all of this whole square. Yes or no? Yes or no? Yes or no? How will you resolve this part? Determinant of adjoint of B into determinant of adjoint of A. Yes or no? Determinant of adjoint of B into determinant of adjoint of A. Yep. Determinant of product is product of individual determinants. Moving ahead. Now we have 3 to the power 4 as it is, 1 upon 2 to the power 6 determinant of A whole square. 2 to the power 6 determinant of A whole square. Perfecto. Up next, what was the expression? Quickly check, quickly. It was 4 to the power 6 determinant of B whole square. 4 to the power 6 determinant of B whole square. Up next, what did we have? 1 upon adjoint of B determinant into adjoint of A determinant. Let's see this. 1 upon, what is determinant of adjoint of A? It is determinant of A to the power n minus 1, determinant of B to the power n minus 1. Yes or no? Now this gets cancelled out. What am I left with? I'm left with 3 to the power 4 into 4 to the power 6, which is 2 to the power 12. Alrighty, this is 2 to the power 6. Yes, here I have what? Determinant of a whole square, which is 3 square, and determinant of a whole square, which is again 3 square. So 3 to the power 4 gets cancelled out. You are left with 2 to the power 6, which is your final answer. Wasn't it fun? Wasn't it fun? Wasn't it fun, people? Is this question hashtag HDCC? Is it high definition crystal clear, everybody? This is how you have to understand what the question demands. This is how you should have all the properties on your fingertips. This is how you apply them. Very carefully proceed with them step by step. These questions are calculation wise very sensitive, demand a lot of your attention, and that's how you reach to the final answer. Correct answer, 4 marks in your pocket, just like that. Let's take a look at the next question. Are you ready? So this question has been cracked. We have solved it. The right answer is 2 to the power 6, which is nothing but 64, option C. Up next is this question. Fantastic question, people. It's a fantastic question. Was asked in 2023. Here a matrix A has been given 3 cross 3 and you have to compute the value of this expression. Now this expression is very familiar. The moment you see this, it should strike you. Adjoint of A square, right? A square treated like a matrix B. Determinant of adjoint of B is determinant of B to the power n minus 1 square. Yes or no? This will give you determinant of A square to the power 4, which will give you determinant of A to the power 8. Why? Because determinant of A to the power n is determinant of A whole to the power n. So this 2 actually jumped out, got multiplied with 4, and you're getting 8 as the power. That means if I want the value of this expression, I eventually need to compute the value of this expression. Which one? This one. All I need is determinant of A. I will raise that number to the power 8 and that is going to be my answer. Now that means all we need to compute is the determinant of this matrix. What is this matrix? 1 log y to the base x, log z to the base x, log x to the base y. This is 2. This is log z to the base y. Here we have log x to the base z. Here we have log y to the base z and then 3. Now I have a smile on my face because this question will not just teach you how to apply the properties of adjoint that we have just learned, but in fact, there is a bonus. The bonus is right now I'm going to teach you a killer shortcut. I will teach you a killer shortcut which is fantastic. It's super lovely, very cute, very easy to understand. That shortcut helps you calculate the determinant of a 3 cross 3 matrix in 10-15 seconds. That's it. That is it. That is it, and that's the power of your hashtag HDCC ma'am. Alrighty. So let's go. What is the shortcut? Because if you apply the traditional conventional method, you will have to expand the determinant with respect to a row or a column. And then you have so many entries. It's a super expansive method where the chances of you committing a mistake are supremely high. And that is what we don't want. If we want to excel in our exam, the negative marking scope should be minimized as much as possible. So what is a shortcut? Let's learn this super killer, awesome shortcut. What is it? This shortcut is very beautiful. What does it say? This says you have to compute a quantity corresponding to the principal diagonal minus a quantity corresponding to the non-principal diagonal, and that is going to be the answer for determinant of A. So let's understand. Principal diagonal means 1 1th element, 2 2th element, 3 3th element. So you catch hold of the principal diagonal. This is your principal diagonal. Multiply the entries sitting here. 1 into 2 into 3 will give you 6. Plus, now you go in either above direction or below direction and catch hold of the parallel quantity to this principal diagonal. So parallel to principal diagonal, if I go above, is this quantity. You went above, caught hold of the parallel. Opposite to this parallel, the quantity sitting alone is this one. Multiply these three. What three? What three, ma'am? This one, this one, this one. What do you do? Principal diagonal, multiply the three quantities. Okay. Plus, go above, catch hold of the parallel. And also catch hold of the alone quantity sitting opposite to it. Multiply these three numbers. What do you get? What do you get? Tell me. You get log y to the base x into log z to the base y into log x to the base z. This is very simple. It's very simple to simplify. Log z to the base y. What is this? Log z to the base y. How can you simplify this? Log z to the base y. You can write log z to the base x upon log y to the base x. And log x to the base z. Log x to the base z will be log x to the base x upon log z to the base x. Cancels out, cancels out, cancels out, cancels out. This is nothing but 1. Right? So the next quantity you are getting is 1. Plus, now do the same thing with respect to the next direction. Let's do the same thing with respect to the next direction. What do I mean? So you went above the principal diagonal. Now I will urge you to go below the principal diagonal. It is this one. Right? And the quantity sitting opposite to it alone is this one. Multiply them. Multiply them. What will you get? Quickly, quickly, quickly. It's very, very simple. It's very, very simple. Log x to the base y into log y to the base z into log z to the base x. Again, guys, this is nothing but 1. You know the log properties, apply them. It's just going to come out to be 1. And hence, here I'm going to write again 1. That's it. This is the task which you have done corresponding to the principal diagonal. Okay, this is partial value of the determinant minus the same thing you have to do with respect to the non-principal diagonal. Are you ready? Are you ready? Are you ready? The same task, same job, absolutely same job. So you catch hold of the non-principal diagonal. You catch hold of the non-principal diagonal. Multiply these three entries. What are you getting? 2 into log z to the base x into log x to the base z. Now log x to the base z is nothing but 1 upon log z to the base x. So when you multiply, things get cancelled out. You are left with just a 2. Now, go either above or below, catch hold of the parallel one. Let's say I go here and the quantity sitting opposite is 3. Log x to the base y into log y to the base x is 1. 1 into 3 will give me 3. Plus, I'll do the same thing. I will do the same thing now in the other direction. So, I will catch hold of this row. Log y to the base z into log z to the base y into 1 will give me just 1. Okay, so while I was teaching you, because I'm teaching you, it's taking a little bit of time, but when you actually learn and apply it in a flow, 10 seconds, people, 10 seconds. 15 is also, I've said much, 10 seconds. So this will give you 8 minus 6. This is 2. So your final answer comes out to be what? Determinant of A is 2. What is the final answer? Remember, all we wanted was determinant of A to the power 8. That means your final answer is coming out to be nothing but 2 to the power 8. That's your final answer. Easy peasy lemon squeezy. So this is how you actually crack a question in a very short span of time by number one, remembering the properties, understanding that how and when to apply them. Number two, remembering these quick shortcuts to compute determinant of a 3x3 matrix. I will be teaching you many shortcuts along the way. So don't forget to tune in to my sessions whenever I come live and whenever these sessions also get uploaded on the channel. Do take a look, because along the way I keep dropping shortcut bombs. Alrighty, let's go attack the last question here. 2022 3x3 invertible matrix, that's what A is. If adjoint of 24A, the determinant of this is equal to, again, another determinant. Again, a very expansive expression given, people, you can see at the top of my head. Determinant of A whole square is equal to what? Here what we're going to do is, again, play smart, play safe. Play smart, play safe. Catch hold of the left hand side. Then we're going to catch hold of the right hand side. We have to simplify both of them and eventually equate them. That's what the question says. That's what we're going to do. Obey the question. So let's start. Let's start, people. Left hand side. Determinant of adjoint of 24A. Super duper simple. Directly it is hitting which nerve? I am able to recollect determinant of adjoint of A is determinant of A to the power n minus 1. This will be determinant of 24A to the power n minus 1. 3 minus 1. This will give you 24 to the power 3 determinant of A whole square. This will come out to be 24 to the power 6 determinant of A whole square. Okay. So this will be what? 2 cube into 3 to the power 6 determinant of A whole square. Is that understood? Because 2 to the power 3 is 8. 8 into 3 is 24. Right? So I've just simplified it. It's like computing the LCM of 24 and breaking it down in the most reducible form. So you are getting 2 to the power 18, 3 to the power 6 determinant of A square. Okie dokie. Now one more thing which you could have done here. You remember the property, that's an alternate approach. This means alternate. This is an alternate approach. It's also correct. You remember the property that adjoint of K times A is K to the power n minus 1 times adjoint of A. Remember? So adjoint of 24A you can write as, 24 to the power n minus 1 adjoint of A, and then compute its determinant. So 24 square will come out 3 times and you will be left with determinant of adjoint of A. Right? So this will give you again 24 to the power 6 determinant of A to the power n minus 1, which is exactly the same quantity that you were getting using the first method as well. You can check. So it's the same. Whatever hits you, whatever knocks the doors of your memory, use that. Okay, there's no compulsion to use a certain result. If there are 2 results being applied giving you the same answer, yielding you the same output, go ahead. Let's go to the right hand side. Alrighty, determinant of adjoint of 3 times adjoint of 2A. Okay, looks pretty tricky, but I'm not going to panic. I'm going to take a deep breath. Look at it carefully. What does it say? Determinant of adjoint of a matrix. Treat this completely as B. It's okay. We are going to make it as simple for us as possible. Okay? Play safe and go a long way. Determinant of adjoint of B is determinant of B to the power n minus 1. So determinant of this B to the power n minus 1. Now 3 comes out of the determinant with power 3. You are left with determinant of adjoint of 2A. All of this to the power 2. So this is 3 to the power 6 determinant of adjoint of 2A. Determinant of adjoint of 2A to the power 2. So this gives you 3 to the power 6, and determinant of adjoint of A is determinant of A to the power n minus 1. So determinant of 2A to the power n minus 1 to the power 2. So this is 3 to the power 6 determinant of 2A to the power 4. Now further next, 3 to the power 6 as it is, 2 comes out with power 3. You are left with determinant of A and all of this to the power 4. So 3 to the power 6, 2 to the power 12, determinant of A to the power 4. Let's quickly check. 2 cube, determinant of A, whole to the power 4. Yep. Now, left-hand side is equal to right-hand side. So, I'm going to equate them here itself. Let's equate them. This is my right-hand side. Left-hand side came out to be what? Quickly recall. The left-hand side came out to be 2 to the power 18, 3 to the power 6. 2 to the power 18, 3 to the power 6. Let's write this here. 2 to the power 18, 3 to the power 6, determinant of A whole square. Okay. So, this gets cancelled out. You're left with 2 times 3 to the power 6, 3 to the power 6 cancels out. So what you are left with is, you are left with 2 to the power 12, determinant of A whole square is 2 to the power 18. So determinant of A whole square comes out to be 2 to the power 18 upon 2 to the power 12, which is 2 to the power 6. Bingo, guys. You've got your answer. You've got your answer. The answer is nothing but 2 to the power 6, which is written in option C. That's it. That was all about properties of adjoint of a matrix. You don't believe me? This is it, people. This is it. These are just 6-7 handful of properties, and the number of questions I showed you in the beginning, the volume of questions which has been asked in JEE Main in just the last 4-5 years is crazy. It's crazy. Just by mastering these few properties. And I've also taught you how to apply them, how to understand that when, where to apply them. This much if you understood, and from this session I hope you've attained immense confidence on what the properties are and how actually can you apply them. These 4 to 8 marks guaranteed in your pocket, 100%. All right, on this note, it's me, Bhoomika, signing off. I hope you liked the session. I hope you found it useful. If you want more such sessions where I explain you a concept in just a few minutes, then let me know in the comments below. It's me, Bhoomika, as I said, signing off. Do not forget to subscribe to the Rankplus JEE English channel. Bye-bye.